So we are going with testing. Wafer is completed. Fabrication of integrated circuit is completed on the wafer. Now we are testing it. We are going to put the entire wafer on the top of a holder under a microscope, and it is aligned multiple point probe. Testing is done. Okay. And it should be placed on pads. Here you can see probe contacts. Various pads are there. We are going to put it on the pads, and then it will undergo testing. The entire wafer may undergo testing. So which locations the die is not proper, that statistic we should maintain, and we have to give it back for refabrication of that particular small sections of the wafer. Next step, the various, this is automatic process. Testing is can be done automatic process, and based on the IC, if it is a small IC, few milliseconds is enough for doing the testing. If it is complex, bigger IC, so 30 seconds are enough for doing the testing process. So this is about the testing. Next, as I told you, in this automatic steps of testing, it will identify which portion of the wafer it is not a good die, and based on that statistic maintain. Scribble means I showed you horizontal and vertical divisions are there, how we get that square. Scribble means we can cut off and separate each of the square. That is called scribbling. So while doing testing itself, good dies can be taken out separately by cutting the wafer, okay, horizontally and vertical at the appropriate positions already predefined. Okay, so that is called scribbling. And then that what we are printing, the statistics, which die is not proper, that we are printing, and if it is very bad, we can reject those dies. If minute corrections is enough, then we will go for remodification in the IC fabrication. Now you can see here 40 test probes are there. I told you wafer should be tested. It should be kept on the contact pads. So here, this is the wafer kept on the contact pads, and test probes are there, 40 test probes. Okay, all these are test probes which will test which area is good die, which area is bad die. This is the picture. Now after testing is done, good dies are taken out, and we are going for packaging. In the packaging, we have different types. So ceramic packages are there, and ceramic packages, again different types. Mounting types are there. Based on pin counts also, we can classify the packages. And then ceramic packages are high reliable. Okay. And then plastic package is another model which is cost effective, as well as it is also giving more user friendly nature. So ceramic rather than ceramic, plastic is giving cost wise benefit, as well as handling and other things, user friendly behavior is there with the plastic packages. And age old practice is ceramic package. And here you can see different types of ICs. It is based on mounting times or pin counts. And here mounting type, different packages are through hole packages or mounting surface package. So through hole means, PCB, printed circuit board. Okay, PCB, printed circuit board. In the network analysis lab last year, you might have done soldering, desoldering. How you had done that soldering, desoldering? There are holes present. You will insert resistor, capacitor. On the back side, you will do soldering. Okay, so this is called through hole. There is a hole. On one side, you will mount the components. On the other side, you are putting the soldering process, which is connections. Okay, so 3 resistors in series, 3 resistors in parallel. Backside, you will solder them. So backside, you are doing the connections. So this is called through hole packages. And different types again inside the through hole package. It is single inline package SIP, dual inline package DIP, and CDIP means ceramic dual inline package. QIP means quadruple, all the 4 sides. We are having the inline SKD. SKD means skinny. Okay, so skinny package, and then shrink DIP, zigzag inline, then plastic DIP. All this in the meaning itself, I will show you the pictures. In the meaning itself, it will explain how many pins are there and how they are arranged. Single line means they are straight away, on one side only pins are there. Dual line means 2 sides pins are there. Quadruple means all the 4 sides of the IC pins are there. Like that. If the box is, outer box is made up of ceramic, it is called ceramic DIP. If it is made up of plastic, it is called plastic DIP. Okay, the name itself explains the type and model. Now coming to surface mount. Previous one what we have seen, through hole. Through hole means holes are there. One side we insert, other side we give the connections. Surface mount means second side will not come. Only first side you are putting some adhesive, gum type. So you will mount and it will get attached to the layer. Okay, that PCB layer components will get attached when you put it on one side. So that is called surface mount packages. And here there are different types of surface mount. You can see CCGA, ceramic column grid array. Next, CGA means column grid array. Then ceramic pack, which is nothing but ceramic packages. In that again subtypes are LLP, which is the lead-less lead frame package. Then LTCC, low temperature co-fired ceramic. Then MCM, multi-chip module. All these are subtype in the surface mount packages. Now you can, the next one, quad flat packages. So here there is a possibility of up to 256 legs are possible. The main application is it is used in SRAM design, memory design. And four-sided, quad means I told you all the four sides of the IC pins are present. If you see AND gate, NOR gate or 741 IC, only opposite sides there are pins, which is called dual inline package. But all the four sides, four edges we have pins, that is called quad flat. Okay, and these are used in digital signal process also, quad flat, multimedia applications, PC chipsets, all these are the applications where quad flat is used. Now through hole, again subdivisions you can see here, single side pins are there, dual side pins are there, full surface pins are there, and in the full surface plastic pin grid array, you can see that surface is made up of plastic. Okay, that's why the name is plastic. Pin grid, so you can see grid model. Grid model means it is like a bunch of holes at a time. But 741 IC, you can see they are not bunch present, they are in a line, okay, in a disciplined line manner. But here pin grid means they are present very congestively, grid model. But however, while inserting, it can be inserted on the this one, die. Next, dual inline means two sides. You can see opposite sides, pins will be there. Zigzag means here the pins are in zigzag model. The name itself specifies like that. Then single inline means series inline. Okay. So here, this is also single line only, but they are not disciplined single line. They are zigzag. Okay. But here it is single line and disciplined manner. Single inline package, zigzag inline package. Dual means opposite side, and grid array means they are very closely present. It is like a grid model. And surface mount, you see how many types are there. Single type, it is surface vertical mount package. So directly you can insert, no bending in the pins. Okay, there is no slight bending in the pins. Directly you can insert them into the wafer. And dual side, you can see small outline package, thin small, and small outline J LED package. You see this diagram, small outline package. Dual means both sides you are having pin numbers, and you can see they are not vertically inserted. There is some cross type of pin model. Okay, and thin small outline means very thin pins are there, and they are also available outline package. Here J type, the pins are in the model of J type. Okay, that is called a small outline J type. And quad also, quad means all the four sides pins are available. Thin quad means the pins are very thin, so it is the thin quad flat package. And the pins are in J model, then it is called a quad flat JLET. Okay, so these are the different types in surface mount. Next, through hole ceramic DAP is there, simple DAP is there. Full surface means pin grid model is also there. You can see the pictures. You need not draw all these pictures in the diagram, but flow chart is compulsory. Okay, so you can see here in the final exam, if you get all this, you can draw the flow chart only, no need of diagrams. Okay, then surface mount is quadruple side. It is the top surface is made up of ceramic material. It is whether plastic or ceramic. Here it is ceramic type, and quad means all the four sides we are having pin numbers. Okay, so this is about surface mount. Hermetic ceramic package means we are making the pins or the packaging, whatever done, it is isolated or it is separated from the ionic. So whatever external effects are there, we are removing that effects and we are making it possible for electrical connectivity. So that is the terminology hermetic ceramic packages. Okay, through hole and surface mount. Earlier we have seen surface mount, through hole, but they are plastic type. Okay, so these are plastic type. We have seen pictures of plastic type, means the surface is made up of plastic. Cost is less, user friendly, okay, all those things. And here ceramic, the box outer surface is ceramic. From ceramic, pins are coming out. So in ceramic, we are having through hole and surface mount. In plastic also, we are having through hole and surface mount. So you have to remember the flow charts, diagrams not required. Next, design considerations. Okay, we are doing packaging. While designing or while doing the packaging, what are the important considerations we have to take care? What points we have to give importance? So one is thermal considerations, second electrical, mechanical, and thermal mechanical. Okay, here you can see thermal means temperature wise. While doing packaging, how much junction temperature, how much that integrated circuit, the power dissipation is taking place. All those things are come under thermal considerations. Electrical means after doing packaging, whether it is giving favorable behavior for the electrical connectivity. So that is called electrical considerations. Mechanical means we are inserting the components in the integrated circuit or the die which we are making inside the package. So mechanical means we are fitting something. So in that fitting, the stress, how much we are compressing it, what is the thermal coefficient of expansion. Okay, different seasons are there. You know, this wood doors, wood windows, in summer and winter, they expand, contract. Okay, similarly, when we do the packaging, the inside IC is there, whether it expand, contract. What about the thermal coefficient of the material used in the packaging? So mechanical considerations, how we are compressing it, that IC inside the package box. Okay, so these three things we have to give importance. One is thermal considerations, temperature wise. Electrical, how it is giving favorable characteristics for electrical connectivity. That inside IC is important. We are not doing simply like that. We are going to use it in a bigger circuit. So how it is favorably for the electrical connectivity. And last one is mechanical, how it is withholding the different seasons, as well as the stress. We are putting that entire thing inside a box, how it is withholding the stress. What is the thermal coefficient of the expansion, the material used in the packaging, supporting the IC present inside. Okay, so all these things we have to give importance for packaging considerations, three considerations. Now I have a problem here. You can see, calculate number of gates that can be included on a logic gate array chip, which is to be assembled on 100 IO package. Number of pins is 100. Okay, what is the formula? 100 equal to alpha into gate count power beta. Okay, so LHS is 100. LHS is 100 equal to 4.5 into number of gates power 0.5. So now that number of gates you have to find out. This problem, this PPT anyway, I will give you direct formula substitution. Okay. Now another 10 minutes I will take class. After that, the questions for